Okay, so as I was saying, what you want to do will determine the language that you should use. And like I said in the previous session, each language has its strengths and weaknesses, okay? So for instance, right now, a lot of work has been done in Python concerning machine learning and data science, okay? So is R. So chances are that if you want to be doing data science or machine learning, then Python will be a good choice, okay? If you pick languages like C++, yes, there are some work, but the community and the assistance that you may get will not be easier and simpler. Is that okay? So it is always good to know what, or know what you want to do, and your choice of programming language would also be influenced by that. All right, so any questions up to this point? Any questions up to this point? Yes, let's have some questions. I'm stopping the sharing. Let's have some discussions. Yes, if you have any questions, this is going to be our last session for today. Hoping to finish. I have about, wow, 70 more slides. Yes, any questions?
Hello, sir.
Yeah.
Please, concerning your last explanation, that's how to decide on which programming language you want to use.
Yeah.
Please, I want you to please break it down, because finally, I'm a little bit confused about that part.
Okay, so for instance, if my reason for learning programming is data science, right? Then programming languages like R, there's a programming language called R, or what do you call it? Python would be ideal, because a lot of work have been done in this concerning data science and even machine learning. You get it? But if you want to learn programming for the purpose of maybe programming hardware, then you have to learn a language like C or C++, which is quite very good when it comes to doing those things. If you probably want to develop desktop applications, then I'll recommend Java. If you want to do web applications, I recommend JavaScript and maybe Python or PHP. Okay, so remember, with the people who were using scissors, although they were all using scissors, they were using it for different things, and that also necessitated the kind of way they even probably have to hold the scissors, or the size of the scissors, or the design of the scissors they have to get. Is that okay? So knowing exactly what you want to do helps you choose your tools right. That's what I'm talking about.
All right.
Any other questions?
So I want to come in again.
Okay.
All right. Okay, because right now, concerning the pictures, that we have a group of people using the scissors. Okay, and then they were using the scissors for different kind of jobs. Okay, so I want to ask, so in this case, like a program like a Python, can I use a Python to program hardware?
Of course, there are microcontrollers that you can program. In fact, there is a version of Python called Circuit Python, which you can load onto certain microcontrollers and do it. So far as the hardware supported, yes, you can use it. Your computer is a hardware, isn't it?
Yes, it is.
Yeah. So if you pick platforms like Raspberry Pi, you can program Raspberry Pi with Python. You can program some ESP32 with Circuit Python. So yes, you can. Just that usually it is more easy to work with hardware using C++ or C. Personally, I prefer C++ when it comes to writing firmware for hardware. Okay, any other question? Any other question?
Hello.
Yeah.
My main focus for joining this program was I want to go further and do a master's program in climate science.
Okay.
So I had to specialize in either climate modeling and those prediction and predictability.
So technically, your direction will have to be data science, because those modeling and stuff has to do with data, right? So all there is, and maybe a little bit of some machine learning, because the modeling right now, oh, if you want to do some things like predictive models, then you have to incorporate the concept of machine learning. You get it? But in the end, all that we'll be doing here is giving you a good starting point, the foundation that you will build on. Okay, so in our intermediate sessions, our advanced sessions, yes, we will go much. And by the time we are done with this marathon, you would have a clear picture as in what specific things should you even learn in Python to achieve what you want to do. You get a point. So it's actually a good thing you are learning it now, because you definitely need it. You definitely need it.
So that's why I said, okay, why don't I take the opportunity to start the beginning, get the concept. Yeah. Even though once you start the program, you learn it, but once you know the basics, it helps.
Exactly.
So I decided the class because.
Fantastic. All right. Any other questions? Else we quickly move to the next session. Okay, now, since we are talking about programming and we said that the writing instruction sets, right? Those instructions, we have to write them in some form of formats. This format is what we call programming language. So as I'm speaking with you, I'm using English language, and you can understand because you also know English language. Is that okay? So a language technically is a structured system of communication. Okay, technically, whether it's a computer language or human natural language, a language is just a structured system for communication. Is that okay? So when we bring this idea to programming language, then we can define a programming language as a formal language which comprises of a set of instructions that produces various kinds of output. Okay, so all the software you've been installing were coded in some language. Okay, all the software that you were coded in some language, and this language is what we are about to learn. In fact, we are not just going to learn about Python as a programming language, but we're going to learn how to program using Python language. Okay, so just think of it as we are going to learn how to describe ourselves using English language. We could have described ourselves using Java, using French. Is that okay? So in the end, the way we describe ourselves doesn't change from one language to the other. It is the language that changes. That's why the topic for this webinar is what? Programming with Python, not learning how to program Python, whatever. Okay, so that is what a language is. And programming languages are what we use to implement our algorithms. Okay, so if we want to, let's say, print out even numbers, we have to go through some steps. Those steps are what we call algorithms. In the kitchen parlance, we will say recipe. Okay, so your recipe is like the step-by-step process that you follow to cook your meal. Is that okay? In computing terms, we call it the algorithms. Okay, so the way we implement these algorithms is by using programming languages. And you should know there are hundreds of programming languages there, but you should know a couple of them and you are good to go. Is that okay? All right. Now, there are some myths about programming languages too, that one programming language is better than the other. Well, that is never the situation. Okay, I made mention earlier that yes, when programming language, if you look at the evolution of programming languages, you realize that one language came to solve a problem that a previous language was encountering, right? But in solving that problem, they also introduced another problem. For instance, Python is very easy to learn. In fact, when we start coding in Python, you almost think that we are writing English. Okay, compared to C or C++, that is very symbolic. Okay, but by so doing, you compromise on the speed of Python programs. So comparatively, C++ programs are much faster than Python programs. Is that okay? So if I am developing and I am interested in speed, chances of going for C++ is higher than going for Python. So every programming language has its ups and its downs, okay? So that is why you shouldn't fall for the fact that, oh, there is a particular language that is better than another. No, every programming language can be used to do one thing or the other better than another language, okay? Fantastic. Now, the next thing is that there is a certain super programming language. Please note, like I said, all programming languages have their strengths and weaknesses. There is no programming language that can do everything without stress. Along the line, you will face some challenges that another language could do easier and better. Okay, now, there are types, we can categorize the programming languages that we have into different types, okay? And usually the classification key that I want to use, the first one is closeness to hardware. And by closeness to hardware, I mean how close is the language output to the processor. Is that okay? So in closeness to hardware, then we can categorize languages into low-level languages, high-level languages. Some people like to put in what we call mid-level language, but I don't see the essence of that. So for me, I only take them as low-level, high-level. Okay. Now, when we say that a language is, it's a high-level language, you usually see these languages written in English or like natural human languages, okay? For instance, Python, when we are coding in Python, we'll be writing English words, okay? So those are the things that we say that they are high-level language because the syntax is closer to the natural language of human beings. Now, when we say that it's low level, that is when it gets very symbolic, like assembly language and machine language. In fact, machine language is written in zeros and ones, okay, zeros and ones, and it gets a bit better at assembly language where you use something called mnemonics, but it is still very tedious to code in assembly language. Now, one thing you should know is that all high-level languages would have to convert your code to a low-level language. Although we have hundreds of languages, the computer speaks only one, okay? There are hundreds of languages, but the computer can speak and understands only one language, and that is what we call the machine language. So right on top of the hardware is the machine language. So despite whatever language you are coding in, Java, C++, Python, C, Pascal, whatever it is, assembly language, it has to be converted to machine language before the computer can work with it. And the machine language is just made of zeros and ones, okay? So irrespective of the programming language of your choice, everything will come back to zeros and ones. It is the zeros and ones that this hardware can process or understand, okay? So in terms of closeness to hardware, you can categorize programming languages into two, low level and high level. All right, now, another thing that we can use as a key to classify programming languages is their process of code conversion. Now, when I talk about process of code conversion, you see, just a while ago, I said that no matter which language you choose, it will have to be converted to machine language because the computer can only speak and understand machine language. Okay, so this tells you that the programming language's convenience is actually for the programmer, not for the computer. Is that okay? So after you've written your code in whatever language of your choice, and here Python, it will have to be converted to the machine language. Now, there are two ways of doing this conversion. The first one that we talk about is what we call the interpretation. Now, languages like Python, MATLAB, R, PHP, they are called interpreted languages. What happens is that when you write code in this language, when you are running the code or when you are executing the code, it picks one line after the other and executes it. So it takes one line, execute it, takes another line, execute it until it gets to the end, okay? The other version is what we call the compiled languages. Now, compiled languages does things a little bit different. They do things a little bit differently. So when you write your code, compiled languages like C++ will first go through the code and make sure that there are no errors in your code. Now, if there is an error, it is going to throw that error and make you fix it before it even generates the output, okay? But the interpreted languages don't do that. They will start executing the code, but when they come across an error, then they break down, they stop if the error is not handled in the code, okay? So these are also two ways you can classify computer languages. So if we look at this pictorial diagram, for interpreted languages, for compiled languages, we first go from the source code, then the compiler converts the source code to machine code, which then goes to the computer to process. But for the interpreted languages, it is from source code to interpreter to output. So that means that there is no compilation for machine for interpreted codes. Is that okay? So one advantage of this is that because you don't have to wait for compilation to occur, interpreted languages tends to be faster during development, because you don't have to be waiting for compilation and all that. Okay, so when you are coding in Python, at the point of coding, you are kind of faster compared to somebody who will be coding in C++. In C++, any change you do, you have to wait for the system to, what do you call it? Check for errors, compile it, generate an output before you run the output. But the interpreted language skips that compilation process, which makes it seem much faster when you are developing, okay? All right. Then we also have the assembly language. So aside machine language, which is actually the actual language that the computer speaks, the most basic or most lowest language is the assembly language, okay? Is the most lowest. Now, it is difficult to code in assembly language because it is machine architecture specific or processor dependent, right? So for instance, if I were to be teaching machine language today, my computer is ASUS and it is using AMD processor. If you are using an Intel processor, then you can't follow the things I will teach, because assembly language is device specific. That means that if I'm using AMD processor, then for it to work on my machine, I have to use machine codes or assembly language opcodes. We call it opcodes specific for AMD. That means you will also have to use opcodes specific for the Intel processor you are using, okay? So it makes assembly language very difficult and tedious. That means that if we have 1 million different ICs, you have to learn all those assembly languages for all those 1 million ICs, okay? So the high-level languages actually take off this burden by making you write code once, and it takes care of the compilation and the underlying hardware resolution issues. Okay. So there is a program called assembler that converts assembly languages to machine code. Now, let's go back and let me show you something. So for compiled languages, there is a program called compiler that takes your source code. Now, source code is the instruction that you have written in the high-level language. That's what we will be writing, okay? So the things that we'll be coding, we call it source code. Now, after we've prepared our source code, we'll push it to the compiler, which now checks for errors, and if everything is clean, it will convert it to machine code. So in the compilation world, or in the compiled type languages, source codes are compiled by a program called compiler into machine code, okay? But in the interpreter world, we have a program called interpreter that converts your source code to the machine code. And if you are coding in assembly language, then you have a program called an assembler, which converts assembly language into machine language. So one thing you should take note is that no matter what you do, your code will end up in machine language. And when we get to machine language, we cannot distinguish between Python code from C++ code. Everything is zeros and ones. Okay, so take note of that. Okay, now assembly languages uses something called mnemonics, okay, shortcuts or abbreviations for its operation. Now, if you are interested, you can go and read more. But this is a typical example of our assembly language operation. So we have some commands here written in assembly language. We'll pass it to an assembler and a linker program, which then get translated to machine code. So these numbers that you see here, that's the machine code or machine language equivalent of the code we have here written in assembly language. Okay, so like I said, in the machine language version, everything is zeros and ones. And here you can't tell whether this code was written in assembler, in a high level or whatever level language. Okay, the essence, the difference is lost. Okay, still on now machine language. So one thing I need you to understand, though we have hundreds of languages, the only language the computer understands is the machine language, and is the zeros and ones. Okay, so we call it, we can also call it the binary digits or whatever, because zeros and one. Okay, so all this stuff are there. Yeah, I've already talked about these things. Okay, so a typical machine language operation is what I have illustrated here. Okay, so we have high-level language example here. Now this, or we can have a low level like an assembly language also here, right? Then what would happen is that this, if it is an assembly language, it gets converted by an assembler to machine code. If it is a high-level language, then one of two things can happen. If it is a compiled language, then it will be passed to a compiler to convert the machine code. If it is an interpreted language like Python, then it will be sent to an interpreter to be converted to machine code. Okay, so let's look at a typical example of hello world in machine code. Assuming we're coding hello world directly in machine code, this is what we will write. This 0001001. That is the machine code equivalent of the text hello world. Okay, so just imagine you were coding directly in machine code and you made an error. I mean, even if hello world alone is giving you all this, imagine writing the quick brown fox jump over the lazy dogs and you made an error in one of the bits. To be very tedious and difficult to trace it. So one of the importance of using the high-level languages is to make it easy to write codes, because there you can easily figure out errors because you are writing in English, okay, not this gibberish of numbers. Okay, now I have been mentioning text editors, source code. And I said that source code are the codes or the instructions that we'll be writing in the high-level language, right? Now, we will need a place or a program to write that. And the programs that we use for this are called text editors or IDEs. IDE stands for Integrated Development Environment. Now, fortunately, anybody who has used the PC before knows a text editor. If you open your computer, Notepad is an example of a text editor, okay? So you can actually use Notepad to write source codes, okay? There are others like Notepad++, you can all use this. Then we have the IDEs, like I said, Integrated Development Environment. These are comprehensive software with comprehensive tools. So if I use the text editor, for instance, then after writing my code, I have to open command line and use the interpreter to process it directly. But with an IDE, everything could be as easy as clicking a button, okay? So over here, I have some of the top IDEs for Python. Personally, I prefer and I code a lot in PyCharm, but we have Spider, Jupyter Notebook, Rodeo, Tony, Microsoft Visual Studio. Oh, and there is something called Eric. I didn't write it, but yeah, it's good to name something after me. Then we have Wing, Atom. In fact, there are hundreds of these editors, but these are the top ones that people usually use in the Python community. Like I said, personally, I use PyCharm. I use PyCharm a lot. Okay. All right, now there are some basic terminologies that I want us to conclude with. okay, so that when you hear me talk about them tomorrow, you will not be found wanting. So the first one is a program, okay? We have already mentioned this. When we talk of a program is nothing but a set of instructions that the computer has to what? Execute, okay? So it is no different from the program you make at church or you make at an event. They are all programs, because at an event, that small paper that the MC is following is the order of the event. Okay, it's the same thing we'll be doing when we are writing computer programs, and it's the same thing we call a program. Now, the process of writing these programs is what we call programming. Okay, so what we'll be doing in this session is to write computer programs, and the activity itself is called what? Programming. Now, whenever we are programming, just like cooking food, we follow a recipe. In programming, what you call recipe is called algorithm. Okay, so in programming, we call it what? Algorithm. Algorithm. Okay, so if you hear me mention algorithm, it is nothing but the step-by-step process that you have to follow to solve a problem using code. All right, then anytime Python is a high-level language, and I explained that high-level languages are languages whose syntax are written in natural language, like English, right? And Python is one of them. So any code that we write in a high-level language is called a source code. Source code is a code written in a high-level language. So take note of this one too. Still on terminologies. The source code, remember I said that we'll be writing the source codes in text editors or IDEs. Now, after writing them, you have to save it on the computer. So a file, anytime you save something on your computer, it's called a file. So a file that contains source code is called source file. So take note, source code, source file. So the source file contains what? The source code, and the source code is a code that is written in a high-level language, okay? If you don't know what a file is just a sequence of bytes on a storage device. And sometimes some of these files will be organized in folders or directories, okay? All right. I think this is just a repeated file. Okay. Now, if you take a file, every file has three main parts that you should know as a programmer. The first is the path. Okay, so the path is where you can locate the file on your computer. That's the path. So let's say if it's on your desktop, then the path will be maybe drive C, users, then your username / desktop. Then if it's in another folder, you traverse that folder. Okay, so that is the path. And you should always know the path of your file, because without knowing the path of your file, you cannot trace or track your file. So as a programmer, you should understand some of these stuff. Now, the next thing you should know about a file is the name. So every file has a path and it has a name. The name is the unique identity of that file. Is that okay? And every file has an extension. So if you have a Microsoft Office document, you see .doc or .docx, okay? If it is a PDF, you see .pdf. If it is a video file, you see .mp4. If it is a music file, you see .mp3, and so on and so forth. And by this extension, you see the extension contains the format or the rules that helps the operating system to know how it should treat that file. Is that okay? So by knowing these three things, you are good to go. Now, all the source files that we'll be creating in Python will have the extension .py. So anytime you see .py, it means it's a Python source file. Okay. Now, like I said previously, an extension tells the operating system how to handle the file. So if you have a video file and you go and change the extension to maybe .text, you see that the operating system will immediately change it to a text file icon, right? Because that is what you are telling the operating system. But when it tries to open it, then you are going to see gibberish. You get it? So know this. All right, so these are just examples. All right, so also to give you a visual clue. So over here, you see that I have some files in this folder, and each of them, so the Python is .py, and the image is .jpeg, JPEG, then we have .text, and we have .pdf. You can see that all these have different icons, right? All these have different icons. This is a PDF, and as at the time I snapshot this, I was using Chrome as my default PDF viewer. That's why it has registered as a Chrome with a Chrome icon. Okay, so these are the things I need you to understand today. And this will be the end of today's session. Today was for orientation and also to give you intro on what computer programming language is. Now, God willing, tomorrow we're going to start with our coding and the concept of programming. But I'll give you some work and activities to do. I'll post a video of a previous recording of mine on the platform. You would have to follow it to go do the installation of the software that will be needed for tomorrow. So please try, find time, do that installation, watch the video as many times that you have to, and then make sure you have the software installed before tomorrow. Is that okay? All right, so any questions up to this point? Any questions up to this point?
Hello.
Yes, sir.
So I wanted to find out, do we get a copy of this?
Yes, I'll actually share the slides with you.
Okay.
On the platform. Yes, I'll share the slides with you.
Thank you.
Yes, any other questions? Any other questions? Any other questions? Okay. I hope today has been informative, and I hope we join as early as possible tomorrow to start with the whole action. You see, the orientation is always necessary because you need to be in your right mindset if you want to do these things. All right. So if there is no question, then guys, thank you for coming. We are actually in time. It's still 7:56. So yeah, we still have some room for questions. If there is any question, any suggestion, any contribution, any remarks, just let it flow. But I do this assignment for me. I need you to sit down, reflect on what has happened today, and I'm going to upload the video right away. By tomorrow, let me come with a very direct and focused motivation for this training. Okay, if previously you were just here to know more about programming, after this orientation, I expect you have picked a couple of things. So now I want you to direct and zero in on a particular thing that you want to be able to do after this training session. Okay, so do that assignment. I will inspect it first thing tomorrow. Okay, so sit down, find something, the reason you want to learn programming. Okay, get something that is very, very reasonable as a reason. Okay. All right. So any questions, any comments? Yes. Fantastic. All right. So if no questions, then ladies and gentlemen, thank you for joining this session. See you, God willing, tomorrow, same time. Okay. It is still not